Yes, sir, we'll discuss on that.
Okay.
Transaction management we will discuss with the Saga design pattern.
Okay.
Okay.
So how many days it will take ending
Before
the?
Dasara we will complete, sir. I already told you. So in another 10 days, we are going to finish it.
You are going to start, sir, JRTP, sir, after this?
We'll check that, sir. It's not confirmed after that. Dasara
Okay.
holidays are there. Huh? After Dasara holidays, we will start.
Okay, sir. Okay, sir.
Sir, where do we get JSON URLs? Sir?
Which URL?
JSON URLs, provider URLs.
I gave you that my API URLs for you, na?
Yes, sir. In online, sir.
In the notes also I have given the URL.
In the Flex, while retrieving the data, we need to use any delay, sir, like 2 seconds or 3 seconds?
You can
Suppose,
configure, sir. It depends on the requirement. If you want to any delay, you can specify the delay time. You can
if you,
delay by seconds,
mm,
by minutes, by hours, by days also you can delay that.
okay, sir, if you don't use that one, even though it coming like a streaming, sir, or if you use Flex,
No,
or
if you don't specify the delay, it will come immediately. If you want to delay, then you can specify.
okay, sir. Okay.
Sir, in real time, webflux, where will we use, sir?
Sorry?
In real time, webflux, where will
Reactive
we use?
programming, sir, we'll discuss on that.
Hello,
All
sir.
good.
Yeah, I have one doubt. For our REST API, which you gave like for ticketing service, I mean, make my trip service. So I was implemented web client REST calls to that service. So before you explain, I mean, before yesterday, like I've used for tickets, view single ticket, I have used a mono to body to mono. And view all tickets, it's array. So I thought like array of elements it will accept in mono to flux. So I have used it. So my understanding it was like that only. So mono to flux is a array of elements, and say if it is single item, I mean it is body to mono. So yesterday I've seen like people are applying delay. That's what Flux handles. But in my case, both are working. I mean, view single ticket, I've used body to mono and body to Flux for view all tickets. So both are working. I mean, in which cases specifically we use body to Flux that
Sir,
thing.
body to flux, when provider want to send a stream of responses, that means response will not go in one shot. Okay, so if you want to send in one shot, you can do it. But main requirement is when you want to send the response continuously for every 10 seconds, you want to send one record. Then you will go for the flux concept. So to understand that, we need to talk about the reactive programming that we are going to discuss in the coming classes.
Okay, okay.
Can you tell one real-time example where actually we use this flex, sir?
Yes, and the reactive programming, we are going to learn that, sir.
No. Example I'm talking about. Example in the sense real time.
Sure.
Can we say it's a real share market price?
Share market pricing and cricket scores, cricket match scoring and all, we can use the flux.
Okay, sir.
Okay, perfect. Now, let us understand one concept from the data JPA, which is association mapping. Okay, so in order to work with the association mapping, first we need to understand database relationships, guys. So we are working with data JPA and we are performing operations with the database tables. Okay, so in the database we can see relationships among the tables. Okay, what kind of relationships we can see among the tables in the database? The relationships we can see as one-to-one relationship. One table will have a relationship with the another table, which is called as one-to-one relationship. Okay, the example for one-to-one relationship, we can say one person will have one passport. One person will have one passport. Okay, so that means person with passport. The example, person and passport. Person and passport. Person data will be stored into person table. Passport data will be stored into passport table. One person will have one passport, which is called one-to-one relationship. So how we will handle with this? One record in the parent table will have relationship with one record in the child table. So the example, person table will be available, passport table will be available, person ID will be stored into passport table. For example, when you see this, two tables we are going to take. One is a person table, another one is passport table. Now, so in the person table, we have person ID, person name, person gender, something like this. And we are having another table called passport table. So here, passport ID, passport number, okay, start issued date, when the passport is issued, and expiry date will be available for the passport. This passport is belongs to which, as of now there is no relation. ID, name, gender is available. So in this table we are going to store person details, and in this table we are going to store passport details, passport ID, passport number, passport issue date, passport expiry date is available. So let me represent some data. Person ID 1, some name is Raj, and gender is something like male. Similarly, ID 2 and something like John, and gender male is available. Now here when we go for this, passport ID 1 is available and some passport number is available here, and passport issue date is available. Okay, so we will say 26/9/24. Then when it is going to expire, 10 years validity will be available for the passport. So 34 is the expiry. So this is one passport record. But this passport belongs to which person, guys? This passport belongs to which person? There is no relationship between person table and passport table. So how many passports one person can have? One person can have only one passport. Then we are going to store person ID in the passport table. We are going to store the person ID in the passport table. ID 1 is available. So we'll specify person ID as 1. So one table primary key we are storing in the another table as a foreign key. So this is person table and this is passport table. So what is the relationship between person table and passport table? That is one-to-one relationship. One person will have one passport. So when you are having one-to-one relationship in the tables, then in our entity classes also we need to represent one-to-one relation. So to represent one-to-one relation, to represent one-to-one relationship among entities, we will use @1-to-1 annotation. So we are going to create one entity for the person table. We will create one entity for the passport table. tables are having the relationship. Then how to represent that relationship among the entity classes? That's where person table, passport table having entities. Those entities will be represented with a one-to-one annotation. That means one record in the person table will have a relationship with another record in the passport table. In the person table, this ID is a primary key. In the passport table, this ID is a primary key. And in the passport table, person ID is a foreign key. One table primary key we are going to store into another table as a foreign key. So to represent the relation, this is called one-to-one relation. One record, the parent table record, one record in the parent table will have a relationship with one record in the child table. One person will have one passport. So if you have this kind of requirement to represent this one-to-one relationship among entities, we will use @one-to-one annotation. Then after this one-to-one, another important annotation that we are going to use, that is one-to-many annotation. One-to-many annotation. Sir, what is the meaning of this one-to-many? One-to-many, the example, one employee with addresses. Employee with addresses. One employee can have multiple addresses like present address, permanent address, office address, like this. One employee can have multiple addresses. One record in the parent table will have relationship with multiple records in the child table. What is the meaning of this? One-to-many relationship. One-to-many relationship. One record in parent table will have relationship with multiple records in child table. One record in parent table will have relationship with multiple records in the child table. Example, one employee can have multiple addresses. What is the example? One employee will have multiple addresses like present and permanent. Okay. Present address will be available, permanent address will be available, present address will be available, and the permanent address also will be available for the employee. Okay, so one employee can have multiple addresses. So one record in the parent table will have relationship with multiple records in the child table. So how we are going to represent this relationship? Okay, so here employee ID is available, employee ID, which we are going to take as a primary key, employee name available, employee salary is available. Okay, so this is employee table. Here if you take the data, ID 1, name is some John, salary is some 1000, employee ID 2, some Smith is available, salary available as some 2000. So this is our employee table. ID, name and salary is available. Now for these employees, I want to maintain address. So address data I will maintain in a separate table. Address ID, which is a primary key. Then city will be available, state is available, country is available. Now address ID 1, city HUID, state Telangana, country something like India. Now address ID 2 is available, city is some Guntur, okay, city is some Guntur, state is AP and the country is India. Okay, like this there are 2 address records available. Now these addresses belongs to which employee, guys? There are 2 employees available in the table and there are 2 addresses available in the table. Now which address is belongs to which employee? How you will maintain that? So country is available and here you can specify type also, type of the address. Is it a present address, present address, and I can specify permanent address also. Okay, employee table is available, address table is available. But is there any relationship between employee and address, guys? Currently, do we have any relationship between employee and address? Currently, is there any relationship between employee and address table, or there is no relationship between employee and address table?
No relation.
There is no relation.
There is no relationship available. But when we are storing the data in the tables, when we are representing the data, we need to establish relationship among the tables. We need to establish relationships among the tables. So to establish the relationship among the tables, what we will do? Along with this, we are going to take one more column in the address table. That column is going to be employee ID. That column is going to be employee ID, so that we can maintain the employee ID in the address table to understand which address is belongs to which employee. So this address belongs to employee 1, this address also belongs to employee 1. Now we can easily understand the addresses of employee and the address belongs to which employee. Okay, there is a relation. How we are establishing? One table primary key we are storing in the another table as a foreign key. So to establish relationships, one table primary key we are storing in the another table as a foreign key. So this is our employee table and this is our address table. One employee can have multiple addresses. Which address is belongs to which employee? That employee ID we are maintaining in the address table. So employee is a parent, address is a child. One record in the parent table can have multiple records in the child table. One record in the parent table can have multiple records in the child table. Not only employee with the addresses, you can also take an example. You can also take one example. Author with the books. Okay, one author can publish multiple books. Okay, one author can publish multiple books. Example, trainer with the courses. One faculty can teach multiple courses. One faculty can teach multiple courses. And example, another example, category with the multiple products. Category with the products. So in one category, laptops. In the laptops category, multiple laptops will be available. Apple laptop, HP laptop, Dell laptop, like this. So one category can have multiple products. One trainer with multiple courses. Okay. One author with multiple books. One employee with multiple addresses. All these things comes under one-to-many relationship. So when we go for one-to-many relationship, employee table we are calling as a parent table. Address table we are calling as a child table. Address table we are calling as a child table. Okay, guys. Address
Sir.
table as a child table. So one record in the parent table can have multiple records in the child table. So how we will represent this one-to-many relationship, guys? To represent one-to-many relationship, we will use one-to-many annotation. So to represent one-to-one relationship, one record in the parent table will have one record in the child table. When you go for one-to-one relationship, then we will use one-to-one annotation. When you are having one-to-many relationship, okay, so to represent one-to-many relationship, we will use one-to-many annotation. One-to-many annotation. Now, if you see the relationship from employee to address, so if you see the relationship from employee to address, this is one-to-many relationship, guys. This is employee table and this is address table. So if you see the relationship from the employee side, okay, One employee can have multiple addresses. This is called one-to-many. One-to-many relationship. One employee having multiple addresses. Same relationship if you see from address to employee, what is the relationship available? Can we say multiple addresses belongs to single employee?
Many to one, sir.
Can we say multiple addresses belongs to single employee? Can we say this is many to one relationship, guys? Can we say this is many to one relationship now?
Yes, sir.
Sir.
Yes, sir. So what is one to many and what is many to one here? What is one to many and what is many to one here?
Employee to address one to many, sir.
One record in the parent table having a relationship with multiple records in the child table, which is called as one to many relationship. One employee having multiple addresses. So to represent the relationship, employee ID we are storing in the address table so that we can understand which address belongs to which employee. Okay, if you see the relationship from address side, multiple addresses belongs to single employee, so which is called many to one relationship. So when we are working with one to many, from left side to right side it is one to many, from right side to left side it is called many to one relationship. Okay, so multiple records, multiple books belongs to one author, many to one relationship. How we are having one to many? Similarly, we are having many to one relationship. One to one is available and one to one is available and one to many is available. Then similarly, many to one relationship is also available. Similarly, we are having many to one relationship. Many to one relationship. What is the meaning of many to one relationship? What is the example for many to one relationship? Books, multiple books with a single author. Multiple books with a single author, which is many to one relationship. Okay, so what is the meaning of this? Multiple books belongs to many records in one table will have a relationship with the single record in the another table. Many records in one table will have a relationship with a single record in another table. With a single record in another table. Okay, multiple products belongs to single category. Multiple books belongs to single author. Multiple addresses belongs to single employee. Multiple students belongs to single school. Multiple students belongs to single class. Multiple students belongs to single university, like this. So multiple records having a relationship with a single record in the another table, which is called many to one relationship. So these are the database relationships that we are going to see in the projects. One to one relationship will be available. One to many relationship will be available. Many to one relationship will be available. Okay. So now when we are going for many to one relationship, to represent many to one relationship, we will use at the rate, many to one annotation. One to many to one annotations we are going to represent. Okay, look at the table structure. Look at the table structure, how the data will be represented here. Employee address. One employee having multiple addresses. One employee having multiple addresses. So many to one also same. And the next one, another relationship that is available, which is many to many relationship is available. There is a relationship called many to many relationship is available. So what is the meaning of many to many relationship, guys? Any idea? What is the meaning of many to many relationship?
Multiple records in one table will have relationship.
Multiple records will have the relationship with multiple records. Multiple records will have the relationship with the multiple records. So what is the example for many to many relationship? The example for many to many relationship, users with roles in the application. Okay. The example we can say users with roles. Now we can say multiple users will have relationship with multiple roles. Multiple users will have relationship with multiple roles. Users with roles, we can say example. Okay, multiple users can have relationship with multiple roles. Multiple users will have relationship with multiple roles. Okay, so when we are going for this many to many relationship, guys, 3 tables are required. Okay, user table will be available where users information will be stored. Users data will be stored in the user table. Role table will be available. Roles data will be stored. Roles data will be stored, and user roles will be available. There will be another table which is called join table. So which user is having which role? Which user is having which role? That information we are going to store into user roles table. So if you want to establish many to many relationship, 2 tables are not sufficient, guys. We need to take the 3 tables. Okay, we need to take the 3 tables. So in one table, user table will be available. User table will be available, and there will be another table called role table will be available. So in the user table, you can take user ID, name, gender, something like this. In the role table, you can take role ID and role name. Role ID, role name. Okay. Now coming to user table, user ID, username, and the gender is available. Now here let me store some information. User ID 1 and name is some John, gender male. User ID 2, the name is some Smith, gender is male. 2 records available in the user table. ID, name, and gender is available. Okay, coming to the role table, role ID and role name is available. Role ID and role name is available. Role ID 1 and something like admin. Admin. Role ID 2, something like manager. 2 roles are available. 2 users available, 2 roles are available. Now, so how to establish relationship? One user can have multiple roles. Multiple users will have multiple roles. Now, to establish this relationship, these 2 tables are not sufficient, guys. We need to take one more table which is called user roles table. User roles table. So which user having which role? So we will specify that as a user ID and we will specify that as a role ID. User roles table will be created separately, which is called as a join table. So in this table we are going to represent which user is having which role. User ID 1 having role ID 1. User ID having 1 having role ID 2. That means one user having 2 roles. So this is many to many relationship. So this is called many to many relationship. So when you are having many to many relationship, we need to establish the relationship by using join table. We need to establish the relationship by using join table. Okay, so one table having a relationship with another table. Earlier we have seen one-to-one relationship, we have seen one-to-many relationship, and we have seen one-to-one relationship also. One-to-one relationship also. This is one-to-one. Person have a passport. Person ID will be stored as a foreign key in the passport table. One person will have one passport. So the person ID we are storing as a foreign key. And the second relation, one to many, many to one. One employee can have multiple addresses, and multiple addresses belongs to single employee. One to many, many to one relationship is available. Then next one, many to many relationship. When you go for many to many relationship, two tables are not sufficient, guys. We need to establish the relationship by using three tables. We need to establish the relationship by using three tables here. Are you clear with my point? Are you clear with my point?
Yes, sir. Yes, sir.
Yes, sir.
Good. So total, when we are working with relationships, guys, there are four types of relationships we can establish. One to one, one to many, many to one, and many to many. These are the four types of relationships that we are going to establish. So when the DB tables are having the relationship, then we have to represent those relationships in entity classes, which is called as association mapping. When our database tables are having relationships, then we have to represent those relationships in entity classes, which is called as association mapping. Okay, to establish this association mapping in the entity classes, we are using annotations. What are the annotations we have seen? So we will use one-to-one annotation. Okay, and we will use one-to-many annotation, and we will use many to one annotation, and we will use many to one annotation. And to represent the foreign key, we are going to use join column annotation, and to represent many to many join table annotation. So like this, we are going to use these annotations when we are working with association mapping. When the database tables are having the relationships, then we have to represent those relationships in the entity classes, which is called as association mapping. To establish association mapping in the entity classes, we will use one-to-one, annotation, one-to-many annotation, many-to-one annotation, many-to-one annotation, okay, and many-to-many annotation we are going to use. Along with this, when we are setting up foreign key, one table will have a relationship with another table. To establish the relationship, foreign keys are required. So to set up this as a foreign key, this is called as a join column. So which column? One table primary key we will use as a foreign key in the another table, which we are going to configure as a join column. Join column is nothing but it is a foreign key. So to represent foreign key, we will use an annotation called join column annotation. And this is join table. This is a join table because two tables of primary keys we are going to store into third table. Two tables of primary key we are going to store into third table. So for that we are going to use join table annotation. Here it is a primary key and here it is a primary key. So two tables of primary keys we are going to store into third table, which is a join table. So when we need this join table, when we are establishing many to many relationship, then this join table is required.
Sir,
Okay.
can we have one more column in the third table, please?
In the join table, no,
Yes.
only 2 columns.
Okay.
Good. Now, database relationships, guys. So let us see what type of relationship we can see in the database tables. First one is one-to-one relationship. What is the example for one-to-one? One person will have one passport. One person will have one Aadhaar card, like this. So one record in the parent table will have a relationship with one record in the child table. So to represent this one-to-one relationship in our entity, there is a annotation called one-to-one annotation is available. Next one to many. What is the meaning of one to many? So n number of use cases available for one to many. One employee will have multiple addresses. One author will have multiple books. One trainer will have multiple courses. One category can have multiple products. All these things comes under one to many relationship. Okay. So one record in the parent table will have the relationship with multiple records in the child table. One employee will have multiple addresses like present address and permanent address will be available. Okay. To represent this one to many, there is an annotation called one to many annotation is available. Then what is many to one annotation? Many to one annotation, nothing but multiple books with a single author. Multiple books with a single author comes under many to one. Many records in one table will have relationship with a single record in another table. So to represent this many to one relationship, we will use many to one annotation. Multiple users, okay? Many to one is there. Here many to many, multiple users will have multiple roles, user table, role table, user roles table. So here only for this many to many, 3 tables are required to represent the relationship. Okay. Now, when the DB tables are having the relationships, then we have to represent those relationships in the entity classes. The process of representing table relationships in the entity classes is called as association mapping. The process of representing DB tables relationships in the entity classes is called as association mapping. Whatever the database tables available, the tables relationship we are going to represent in the entity classes, which is called as association mapping. So to achieve association mapping, to achieve this association mapping, what are the annotations we are going to use? Okay. To achieve the association mapping, what are the annotations we are using? For this, these are the annotations we are going to use. One to one, one to many, many to one, and many to many. Like this, we are going to represent the relationship. One to one, one to many to one, many to many, and join column, join table. Join column is used to represent foreign key. Join table for many to many relationship. And when we are working with association mapping, we need to understand one concept called cascade. When we are working with the association mapping, we are going to use a concept called cascade concept. Any idea what is the meaning of cascade? Guys, any idea?
Delete one table, other tables also should delete.
What is the
It's
meaning
a parent-child relationship.
When parent is saved, sir, all childs will be saved.
Sorry?
Sir, when parent is saved, all childs are saved in the database. Like
Cascade is basically used to specify whatever the operations we are doing on the parent table, those operations should reflect on the child table or not. Cascade. Parent table operations should reflect on the child table or not, we are going to represent by using cascade concept. Parent table operations should reflect on child table or not will be represented by cascade. Okay, so if I insert parent, along with the parent, child should be inserted or not. If I delete parent, my child record should be deleted or not. That will be represented by cascade. So generally, whatever the operation we do on the parent, those operations should reflect on the child table also. Whatever the operations that we do on the parent table, those operations should reflect on the child table. Okay, whatever the operations we do on the parent table, those operations should reflect on the child table also. For that, we are going to use cascade. Okay, next one. Another concept we will use when we are working with association mapping, which is called fetch type. When we are working with the association mapping, we need to understand fetch type. Okay, what is the meaning of fetch type? Fetch type represents when we are loading parent, child records should be loaded or not. When we are loading parent record, child records should be loaded or not. So when I retrieve employee, along with employee, address records should come or not. That will be represented by fetch type. So fetch type represents child records should be loaded along with the parent record or not. What is fetch type? Fetch type represents child records should be loaded along with the parent record or not. So here we are having two fetch types, guys. We are having two fetch types. One is called lazy, another one is called eager. There are two fetch types available. One is called lazy and the second one is called eager. So what is the meaning of lazy? Lazy means child records will be retrieved on demand basis. That means when you retrieve parent, only parent record will come, child records will not come. But fetch type eager means when you retrieve parent record, along with the parent record, child records also will be retrieved. When you retrieve parent record, along with the parent record, our child records also will be retrieved. Are you able to follow me? Guys, are you able to follow me?
Yes, sir.
Yes, sir. Please follow.
Fetch type represents child records should be loaded along with the parent record or not. We have two fetch types. One is lazy, another one is eager. Lazy is the default fetch type. Lazy means child records will be retrieved on demand basis. Okay. Eager means whenever you load the parent record, along with the parent record, your child record also will be loaded. Along with the parent record, your child record also will be loaded. Are you able to follow me? What is the meaning of a cascade and what is the meaning of fetch type? What do you mean by cascade? What do you mean by cascade? Come on, guys. What do you mean by cascade?
Parent
What do
table
you mean by cascade?
on parent table or not?
Cascade will represent parent table operations should reflect on the child table or not. Okay, parent table operations should reflect on the child table or not will be represented by cascade. Then what is fetch type? Fetch type represents child records should be loaded along with the parent record or not. We have two fetch types. One is lazy, another one is eager. Lazy means child records will be retrieved on demand basis. That means when you retrieve parent, only parent record will come. Then eager means when you retrieve parent, along with the parent, our child records also will be retrieved. Lazy means child records will be retrieved on demand basis. Eager means child records will be retrieved along with the parent record in the single query.
Hello, sir.
Yes.
For cascade, can this reverse be possible? Like any operation on child can have effect on the parent?
No, sir. No.
All right, sir. All right. Thank you.
It's like suppose you have done one Facebook post. In that post, multiple comments available. When I delete the post, comments should be deleted. But if I delete one comment, post should not be deleted.
Yeah, that's obvious. Yeah.
Yes. One
Thanks.
Facebook photo you uploaded, one photo you uploaded in the Facebook or Instagram. You uploaded one photo in the Instagram. For that photo, multiple comments are added. Post is a parent, comments are childs. If I delete post, comments should be deleted. There are 10 comments available. If I delete one comment, my post should not be deleted. So whatever the operation you do on the parent, it should reflect on the child. So that's where cascade comes. Child operation should not affect on the parent. Child operation should not affect on the parent.
Yes, sir. Got it. Thank you.
For one to many, many to one, both are same.
Yes, sir. It depends on from which direction you are seeing that. Employee to address, one to many. Address to employee, many to one. If you see from employee side, it is one to many. If you see from address side, it is many to one.
Combination becomes again many to many, sir, like one to many and many to one.
No.
Sir, in one-to-one mapping, we did like person tables. Primary key ID we have taken as primary key in foreign key in passport table, right?
Correct.
In reverse also we can take like that.
Passport ID also you can show in the person table.
Okay. Same for all the things. One to many and many to one also.
Oh. So if you go for employee and address ID you can't store in the employee table, because if you want to store address ID in the employee record should be duplicated, right? Only in the one-to-one, either passport ID you can store in the person table, person ID you can store in the passport table. When it comes to employee address, so employee ID you need to store in the address table. Suppose if I want to store address ID in the employee, one employee having 3 addresses, then you need to create employee record 3 times. That's not good, right? You understand the problem?
Yeah, okay, sir.
Yeah.
Sir? Hello.
Yeah, hi.
Yeah. So when these directions will be used, like unidirection and bidirection?
So yes, sir. In the implementation, we'll specify that unidirection, direction, bidirection means in the implementation, if both entities have the relationship now, then it is called bidirectional. If only one entity having, that is unidirectional.
Okay. So two table references will suppose for unidirection. So suppose employee and address. So it is a unidirection because employee have one address.
Correct.
And for bidirectional, suppose employee also have a reference to address, then that will be bidirectional.
But bidirectional not at the table level, sir. Bidirectional is at the entity class level, not at the table level.
Okay. So then in which case we use this bidirectional?
That is what I'm telling you. If the employee entity having the reference of address, that is bidirectional. Address is having the reference of employee. If the employee entity having the reference of address, it is bidirectional. That bidirectional, unidirectional only at the entity level, not at the table level.
Okay.
You got my point?
Yeah.
Sir, is there any tool which converts the database schema to an entity class, sir?
Yes, sir. JPA tools available. In our IDE, we can create one JPA JPA project.
Okay, because if the tables are too large and it is very difficult to represent as an entity, right?
I understand, sir. That concept is called reverse engineering.
Okay.
So if you have that tables, you can convert the tables to entity by using Hibernate reverse engineering process.
Okay.
So what is meant by other tables, sir?
At the rate
Tables, sir.
to map your class name to the table name.
Okay, sir.
At the rate table, it is used to map your class name to the table name. If you don't use it, your class name will be considered as a table name.
Okay, sir.
Okay, good. So theoretically, we understood what is the relationship and what type of relationships we can establish among our entity classes, guys. What is the example for one-to-one, example for one-to-many, example for many-to-one, example for many-to-many, and what is cascade and what is fetch type. In the tomorrow session, we are going to implement a project with these relationships. So today, I want you people to do some research on this. I want you people to do some research on this before coming to tomorrow class. How to create entities with the one-to-one relationship. How to create entities with the one-to-one, many-to-one, and many-to-many. So whatever the examples I have given, same thing. Person entity, passport entity, try to establish the relationship. Employee with address, try to establish the relationship. Users and roles, try to establish the relationship. So today you have time to do some research on this association mapping, how to design these entity classes. So tomorrow I will explain how to design the entity classes with the association mapping. Okay, in the tomorrow session we will work on the coding part. So please do some analysis, try to do this assignment on your own before coming to tomorrow class. Is that fine for everyone? Good. So take one project. In that project, you need to take person and passport and establish the relationship. Take one more project, employee address, try to establish the relationship. And take one more project, users and roles, try to establish the relationship. So one-to-one, one-to-many, many-to-one, many-to-many. These relationships we need to implement practically by creating entity classes. And we need to implement cascade and fetch type while performing the operations. Cascade will represent parent table operations should reflect on the child table or not. Fetch type will represent when to load the child records. Do we need to load the childs along with the parent, or we should not load the childs along with the parent? That will be represented by using our fetch type. Is this clear? Good. Fine guys, thank you. With this I'm stopping for today. Tomorrow we will work on the coding part for this association mapping. Try to do it before coming to tomorrow's class. Any questions, anyone?
Hello, sir.
Yes.
Sir, these relation annotations are called as data JP annotations.
Sorry, your voice is breaking for me.
Sir, one-to-one, one-to-many annotations called as data JP annotations.
Database?
Annotation. Data JP annotations not sure.
No, these are association mapping annotations.
Okay, sir. Okay. Yes,
These are used for association mapping. So these are called as association mapping annotations.
Okay, sir. Thank you, sir.
Yeah. Guys, these notes I'm going to update in the JPA part, guys. Data JPA notes I have given now. In that notes only I'm going to update this association mapping. When you are opening the portal, you can check for these notes in the JPA part. So association mapping related to JPA, I'm updating that to JPA nodes. Okay, good. Thank you. I'm stopping now. We'll meet in the tomorrow session, guys.
Hello, sir.
Yes.
Sir, long back, I asked regarding that we had gone through that mock interview, right? So, can
I
you?
will take that mock interview once again, sir. I think we lost those videos. I will take that again. Okay.
Okay, sir.
Sir, I have one question. SLF4J just like a interface, sir, like API, and we can provide any implementation like log4j, logback.
SLF4J is the interface. For that, log4j is a implementation.
We can use like a logback also, sir,
Yes,
log4j
sir.
too.
Anything you can use.
Anyone we can use. API we are using, sir, just
Yes.
SLF4J.
Yes.
Okay, sir. Okay. Any benefits, sir? SLF4J, any benefits are there, sir?
You
Actually,
can change log4j implementation, sir. You can use log4j, logback, logstash, anything you can configure while running the project.
okay, sir.
It
We
will make
can.
your
We need to.
application loosely coupled with the logging framework.
Okay, sir. Okay. Okay, sir. Thank you.
Okay. Thank you, guys.